let's say I have my little yellow ball here, and I tie it to a bit of string, and I hang it on something, maybe the edge of my table, or a tripod, or a ceiling, and then I pull it to one side. And I let go. Then it goes swinging to and fro. Put it there. Okay, and then I let go. So it will swing. It will swing to the left, and it will swing to the right. Okay, so there's this swinging motion that we have. Now let me also look at another example where I take my the yellow ball. Now this time, instead of tying it to a bit of string, this time suppose that I attach it to a spring. I attach it to a spring. Okay, or either a spring, or I can attach it to a rubber band, just something elastic that can stretch. Okay, and I fix the other end again at the edge of my table, or some supports. Now then, I'll pull this down. And let go. And when I do that, my little ball will spring back, overshoot its original position, and come down again, and it would keep going. It would go up and down for a while. So it goes up and down. So again, it's this kind of motion. This is up-down motion. This is a left-right motion. But both are motion that goes to and fro, back and forth. Okay, we describe this kind of motion as an oscillatory motion. So these kind of motions are called oscillations. They go back and forth, and they keep repeating. The motion keeps repeating itself. Okay, they go to and fro about the same place. So there's something common between these two types of motion. They both go back and forth, and they both have a rest position. If they don't move, or if they slow down and stop, they will stop at the rest position. And when the ball gets displaced or pulled to one side, there would always be a force that pulls it back to the rest position. So let's write down some names. Let's write down some names. Okay. This is if we put the ball down here, it would spring back. Okay, so we would call this, and this position, we would call this the rest position. So that's also a rest position. That's one name. There are other names. We'll talk about those later. And if I pull it out to this far and let go, it will keep swinging. Okay, but the biggest distance would be that distance. Let's see, would be this distance. And in this case, the biggest distance, if I pull it down and let go, and it goes up and down, this would be the biggest distance. Okay, so the biggest distance has a name. Biggest distance, the biggest displacement from the rest position is called amplitude. Amplitude. Okay, the same for this case. Amplitude. Okay, and then let's also think of some other quantities, some other things about the motion, about this motion that are in common. This amplitude, it's the rest position, goes back and forth, and there is and it goes back and forth, and we have the idea that it probably goes each time it goes back and forth. It takes a certain time, right? And we might have the idea that the time is always the same, right? When it goes back one way and come back to the same place, the time taken is called 1 period. So we have period, right? So let me write down the word period. Period is the time for one cycle. And then we have this idea of a cycle, right? A cycle. A cycle is this motion, the part of the motion where it repeats itself. So starting from there, it goes there and come back. So so the motion keeps changing, but after it comes back to the original place, that motion repeats itself. It goes back and forth. Okay, so a cycle is a part of the motion that keeps repeating itself. So the part of the motion that repeats. Okay, so period is a time, and we could represent it by a symbol t, like t seconds or t minutes. Cycle is just a description of the repeating part of the motion. And we talked about amplitude, and there is displacement. If the ball is at a certain position, it can be maybe the amplitude, or at some other point in the motion, it has a certain displacement. Let's see. So at a certain part of the motion, let's say when the ball is at a certain position, it has a certain displacement. I'll call that x. So the x will keep changing as the ball moves up and down. So we think of x as a displacement. Okay, the displacement from the rest position. And you can see from here that it's sometimes, for the spring, it's sometimes on one side of the rest position, sometimes on the other side, and in the pendulum it's sometimes to the right and sometimes to the left. So this displacement has a direction, okay? And we can think of it as a number, and we can give positive and negative signs to the two directions. Okay, so x is the displacement, and then there is the idea of a frequency. Now, when we talk about period, it's the time for one cycle. Now, then we have the idea of a frequency. Frequency means, let's say in 1 second, this swings a few times. Okay, or this goes up and down a few times. So it makes a few cycles in 1 second. So we say that the frequency is the number of cycles per unit time. So the number of cycles per unit time, as in unit time can be any unit, like seconds or minutes or hours. SI units would be seconds. So the number of cycles per unit time is the frequency. Now there is actually a name for the SI units of frequencies, and it is this. If we have 1 cycle per second, then the SI unit given to this is called 1 Hertz. 1 Hertz. short form is Hz. So meaning that if this swings 2 times in 1 second, then we say that its frequency is 2 Hz.